as a continuation to the previous question that you have done, you have proved root 3 is irrational. Okay. Now, root 3 is a pure irrational number. That question, if they ask you to prove that one, you have to do such a long way. Now, what you learned already, root 3 is irrational, you are going to apply in other mixed irrational numbers. What I mean by mixed irrational number? See this one. Prove that 5 plus 2 root 3 is irrational number. Of course it is irrational. Because this 5 is rational number, 2 is rational number, root 3 is irrational number. So you learned in class 9th. If you add, subtract, multiply, divide a rational number and an irrational number, a rational number and an irrational number, you always get what? An irrational number. If you add, subtract, multiply and divide one rational and one irrational, okay, then you are getting always an irrational number. In that way here 5 added with the 2 times 3 is irrational, of course. So now how you give proof using the previous question you have done? You can even call it as a theorem, because the theorem says root 2 is irrational, we did root 3 is irrational, nothing different. Okay, so now look how you do. You don't have to do such a long way, and you are applying root 3 is irrational here. Alright, now look, as usual, as we have done in the previous question, you are taking, if possible, let us assume that 5 plus 2 root 3 is rational. You are assuming it is a rational number as we did in the previous question, okay? So what do you do naturally? 5 plus 2 root 3 is equal to P by Q. You are expressing like that. Where P and Q are integers, Q not equal to 0. You have to write this. Alright. Now what you do? This root 3, the root 3 alone isolate at the left hand side and transpose remaining everything to the right hand side. Got it? So you isolate root 3 one side and remaining transpose to the other side. So how it transpose here? 5 by first transpose. So 2 root 3 is equal to P by Q minus 5, and I take LCM here, okay. So P is multiplying 5Q, P minus 5Q by Q by taking LCM. Multiplying here and putting the denominator Q. Then you are transposing the 2 also. 2 transpose the 2 goes here. So you get root 3 is equal to 5 minus, P minus 5Q by 2Q. So now come to this. This is a contradiction. You know why contradiction? What is contradiction here? Earlier we know, this we applied directly what you learned before. We know root 3 is irrational number. Why do we know? We learned already. And you can call the theorem by that theorem. Root 3 is irrational number. Why at the right hand side you see? I will say right hand side is rational number. You know why rational number? Because P and Q are integers. What happens? P minus 5Q will be integer. This is property of integer. Okay, if P and Q are integer, P minus 5Q or any number of times Q will be integer. Same way Q is integer, naturally 2 into Q. Any integer multiplied by 2 is also integer. So what happens? This is a fraction having numerator and denominator integers. Denominator not equal to 0. So what happens? This will become rational number. Ultimately we get an irrational number equal to a rational number. It is impossible. No irrational number can be equal to a rational number. So that is why we call it as a contradiction. Here we say this is a contradiction because root 3, the left hand side of the statement, root 3 is irrational number. Whereas the right hand side we obtain. The right hand side after transposing and all we get this. This is rational. So irrational number cannot be equal to rational number. That is why this is a contradiction. Why this contradiction came? As they have expressed as P by Q. So this contradiction arose out of the wrong assumption. I assume it is rational. We cannot assume in that way. As I assumed, I took it as P by Q and then the controversy or the contradiction arose. So what you can say? This contradiction is because of our wrong assumption that 5 plus 2 root 3 is rational. So What we conclude? Hence 5 plus 2 root 3 must be, here's the mistake, must be irrational, cannot be rational. Okay? Cannot be rational, must be irrational. If I take it as a rational number, then I am getting a contradiction. So 5 plus 2 root 3 must be irrational. Okay? Any question of this kind, mixed numbers having a irrational factor in it, asked, you do the same way. Write it as P by Q and transpose, isolate the irrational factor one side and transpose every other to other side until that the left hand side is irrational and the right hand side is rational and it is a contradiction. Same steps. See, this is one of the questions from your book. Similar question is there. 4 times root 2. See, here I wrote it as question number 2. Prove that 4 root 2 is irrational. Same procedure you follow. Right, 4 root 2 is equal to P by Q. Root 2 isolate in left hand side and transpose 4 other side and you get like this until left hand side is irrational and right hand side is rational, etc., etc. Same steps. Repeat again. Okay? This is the way you have to do it. Now let us take one more question. This question is a bit different from the previously discussed question. Come to this question number 3. Let's take question number 3. See now look. I am going to prove here 3 plus root 5 is irrational. If I add root 3's value and root 5's value, non-terminating, non-recurring decimal digit is to come. Okay, look at this question. This is different from the other 2 questions we discussed. See, root 3 plus root 5 is irrational. Of course, why no? Root 3 is irrational number. It's a non-terminating, non-recurring decimal. Root 5 is also like that. If we add them again, it goes to non-terminating, non-recurring decimal only. And it is irrational. So how you give this type of proof now? Here you take, let us assume that as usual, root 3 plus root 5 is rational and let this is equal to P by Q, where P and Q are integer, Q not equal to 0. Like the previous question, what you will try to do? You will transpose one of them other side. Like root 5 you keep here and P by Q minus root 3. If you try to do like that, you cannot argue. Whatever LCM you take and all, this is irrational and here also irrational. Both the sides will be irrational. Because you have 2 irrational factors here and no rational factor over there. So this problem will come. You cannot tell that root 5 is left side is irrational and right side also irrational then. So that will not work here. In this type of question, what you have to do, you just square it. Both the sides square it, okay? When you square, root 3 plus root 5 the whole square is equal to P square by Q square will come. Expand using our A plus B the whole square formula. If we expand, root 3 square is 3, root 5 square is 5 and 2 root 3 into root 5 is 2 root 15 and you can add these 2 rational factors, 3 plus 5 is 8. Okay, now the question becomes the older question, the previously learned question. Now you can easily, here with 8 came, this 8 you transpose, the 2 you transpose, hold the root 15 at the left hand side. Is the irrational factor. Hold it left side, all other things you turn to right side, means transpose to right side. You have done it here. 2 root 15 is equal to P square by Q square minus 8. Take LCM and the 2 also and transpose other side. So left side coming root 15, right side coming P square minus 8Q square by 2Q square. And again tell the same dialogue. What it is? Left hand side is irrational and the right hand side is rational. It is contradiction. The contradiction arises out of, as you have assumed as rational. So root 3 plus root 5 must be irrational. Conclude like that. And you do please write this. Because how it is rational you have to tell. When P and Q are integer, P square minus 8Q square will be integer, 2Q square is integer by the property of integer you tell. Therefore it is rational. This is irrational how? This is we know already. You take it as we know. Like previously learned question. This is irrational. This is rational. Contradiction. Okay? Like this you do. All the textbook questions please do it from your book. It It is just only number different, all other things are nothing but the same.